In this video, we'll take a look at notes for sections 13.4 and 13.5. So in the first three sections, you took a look at exponential and then logarithmic functions. Today, we're going to look at logarithms in special bases, base 10, called the common logarithm, and base e, called the natural logarithm. So in section 13.4, base 10 logs were developed for calculational purposes and were used for making calculations until the 1970s, when the modern scientific calculator became widely available. So we use our calculator now more than base E logarithms, but we still use them in several scientific measurements, and we'll see that we use Richter scale earthquake measurements on base 10. And base E logarithms are used in technical and scientific work, so we'll take a look at those as well. So if a logarithm is in base 10, it's called a common logarithm. They can be found directly on a calculator using a log key. The calculator key indicates the common notation, and when no base is shown, it's assumed to be base 10. So using a calculator to find the log of 426. So log 426, there's no base, so that means log base 10. So if you have a calculator, see if you can find the log key, log. If you hit log 426, in parentheses, equals, or enter, we get the 2.629. Notice we had to round it to 3 places. This is a decimal that goes on forever in this particular case. So what did we just find? That means if you take 10 to the power, rewrite it as an exponent, 10 to the power of 2.629 is going to be approximately 426. So let's see what happens when we take 10 to the power. Notice above the log key on mine, I have 10 to the power of x, or you can type in 10, the power key, 2.629, enter, and notice it's 425.59. That's not exactly 426. So the more spaces that you round to on the exponent, the closer you'll get. So 2.629, and let's say we win a few more spaces, 4096. So if I round to more decimal places, I'll get a lot closer to 426. So when we're finding logarithms, usually we'll round to at least 3 decimal places, and more would be more exact. So another example, use a calculator to find log of 0.03654. So these aren't things that we can just find if you don't have a calculator, so we have to use the calculator. Notice this is a decimal number, log of 0.03654. And we end up with a negative. So that equals negative 1.437 to 3 decimal places. So if you're taking a log of a fraction, remember that negative powers make fractions. The answer to a logarithm, a common log, is a power of 10. So 10 to the negative 1.437, just to check and make sure you're right. 10 to the power of negative 1.437 is equal to about 0.036559, so close. All right, so that's the first idea, is base 10, called a common logarithm, and how to find them on a calculator. Now, sometimes you'll want to go backwards. What if you know the power of 10? Or you know the antilogarithm? Next vocabulary is antilogarithm. We can also use a calculator to find a number n if we know log base n. So in this case, the n is called an antilogarithm of log n. So here's what this means. On our example, given that the log of n is equal to 1.1854, convert this to exponential form. This means that 10 to the power of 1.1854 is equal to capital N. So the antilogarithm means take 10 to the power, the logarithm, log base 10, is the power of 10. Okay, so on the calculator, 10 to the power of 1.1854 is equal to 15.325. All right, so those are the ideas in this section. Then there's a couple of different ways to use the ideas. Clear this out. First example says, use a calculator to verify the given values, that the log 10 plus the log of 0.5 is equal to the log 5. So we just want to verify that's true. If you remember from a previous section, that properties of logarithms mean that you can combine these logarithms. When you add, that means that can be the log of 10 times 0.5 equals the log of 5. So what we're going to do, we're going to verify the addition rule or the multiplication rule. So log of 10 times 0.5 is log 5 equals log 5. That's using the properties. What we want to do here is use the calculator to show that it's true. So the log of 10, remember the property 10 to what power is 10, is 1. And we want to go 4 decimal places, plus the log of 0.5. So I'm going to take in here log of 0.5 is a negative 0.4 decimal places, 3010 equals the log of 5. So we have the log of 5 is 0.69897. So if we round to 4 places, that 9 is going to round up to a 0, 90, 89 rounds up to 90, so 0.6990. And you can check that 1 minus 0.3010 is about 0.6990. Second type of problem that you'll have on homework, this one is for earthquakes. Measured on the Richter scale, the magnitude of an earthquake of intensity capital I is defined on the Richter scale as log of capital I divided by I subscript 0, where I sub 0 is a minimum level for comparison. What is the Richter scale reading for the earthquake in which capital I equals 66 million times I subscript 0? So what we would do to find the Richter scale, we would take the log of the value we're given, 66 million, times I subscript 0 divided by I subscript 0 means these I subscript 0 canceled out. And you would type in your calculator the log of 66 million. I think I can, let's see, so that's a 66 right there. Sorry about the writing. So on the calculator, log of 66, and make sure you have enough zeros, 4, 5, 6. Enter, so that would be about a 7.8 on the Richter scale. So an earthquake with 66 million intensity is a 7.8 on the Richter scale. All right, so that's common logarithms. The next section is called natural logarithms. So another important base of logarithms is the number e. The number e is an irrational number like pi. E is approximately 2.718. It actually goes on forever. If you have a calculator that has an e value on it, and mine is right here above the division key, if you take e to the power of 1, that will tell you that e is about 2.718281828, and it goes on forever. It's irrational. So this is a number that comes up quite a bit. So just as log x refers to logarithms to base 10, the notation ln x is used to denote logarithms to the base e. So if you have logarithms to the base e, we don't write log base e of x, we write it as ln of x. Okay? So example, use a calculator to find the natural log of 236.5. Let me clear natural log of 236.5 equals to 3 places 5.466. So this means if we were to take e to the power of 5.466, we would get approximately 236.5. Okay, so it's just like common log, except we're base e. So if you want to try it out, you take e to the power of 5.466, and we get very close. It's 236.51. Okay, then just as we can find a logarithm, we find an antilogarithm. The natural antilogarithm means that the log of something is equal to 1.773. So antilogarithm means we're given the power, find e to that power. So we take e to the power of 1.773, and that will give us our n. So we take e to the power of 1.773 and end up with approximately 5.888. All right, so we use calculators for natural logarithms as well. But notice the only two logarithm buttons on your calculator are log base 10 and log base e. But we can have a logarithm with any base. So that brings us to the next part of notes, which is something called a change of base formula. So if we want to find logarithms to other powers besides e and 10, for example, log base 5 of 560, we can't just type it in the calculator. So we have something called a change of base formula. Notice it says log base b of x can be written as log any base x divided by log any base b. So we're going to pick a base that's in our calculator. So to find the log base 5 of 560, we're going to use the log base 10 of our calculator. It's log of x, log of 560, divided by the log of 5. Okay, so in this case, b is equal to 5, and a is equal to, or x in this case, is equal to 560. Now we can use the calculator. So let me bring back up the calculator. And I'll put parentheses around just to make sure it doesn't get confusing. So that's log of 560, and make sure that the calculator does the order of operations I want. There's log 560 divided by log 5. Enter, I get about 3.932. So that means that log base 5 of 560 is approximately 3.932. If you want to check and make sure you're right, take 5 to the power of 3.932, and you should get about 560. All right, last example. Find log base 2 of 15. So you also have common logarithm in the calculator. So if you want to use common log or natural log, you could also write this as natural log 15 over the natural log of 2. It doesn't matter what base, you just want to use one that the calculator has. So natural log of 15, got the parentheses, divided by the natural log of 2, got the parentheses, is equal to 3.907. And notice if I would have used common logs, log of 15 divided by the log of 2, I get the same thing. Change of base formula means you can change it as long as the base is the same and use one of the bases that our calculator has. All right, last idea, properties from section 13.3 also work with common logs and natural logs. The one that we're going to use for the natural logs in this example, and this is like the one on your homework, is that if you have a log base b of b to the x, it equals x. That's the power. So if you have natural log of e to the power of x, that equals x. Or natural log of e to any power, 3, is equal to 3. So we use this in simplifying expressions that look complicated. This might be tough to put in the calculator. So we want to find the square root of the natural log of e to the power of 81. But if we use the property, natural log of e to the 81 is just 81, and the square root of 81 is 9. So that problem looks really complicated, but if we use one of the properties and simplify, then it's a little bit easier to do.